0.5 from both sides. So I have S minus 23.5 equals 2 times the log of D. Then what?
Divide each side by 2.
Yep. Nope, just divide both sides by 2. So I have S minus 23.5 divided by 2 equals the log of D. Now I gotta get D by itself. Okay, so what is the base of my log? 10. So I'm gonna make the base both sides 10. So D equals 10 raised to the S minus 23.5 divided by 2. Questions? Okay. Here I want to solve for X. What would you recommend my first step be?
T over to the other side.
Yes, add T to the other side. So 3 times e to the nx equals 4.2 plus t. Then what? Okay.
Take the log of both sides.
Okay, but careful.
Natural log.
Take the natural log of both sides. .2. So then I have n times x equals the natural log of 4.2 plus t divided by 3. And then I would divide both sides by n. Questions? Doing okay with this?
Are we allowed to have a double division like that?
Yes. Because what this actually is that's the natural log of 4.2 plus t divided by 3, and then that whole thing will be divided by n. Okay? Do we need to do any more of these? Got a pretty good handle on them? Okay. So we'll create models for exponential growth and decay. Let y be a variable changing exponentially with respect to t. Let y sub 0 represent the initial value of y when t equals 0. For a positive constant k, y equals y sub 0 times e to the kt is the model for exponential growth. For a negative constant k, y equals y sub 0 times e to the kt is a model for exponential decay. So whether we have exponential growth or decay will rely on whether k is positive or negative. Okay, y sub 0 is always your starting amount. Okay, so suppose that at 19 years old you win $100,000 playing lottery. If you'd like to have $1 million when you retire at age 67, determine the average rate of return needed under continuous compounding. So I know, here's my formula, y equals y sub 0 e to the kt So, I know I would like $1 million. And I'm starting out with 100,000 times E to the K and then T. Well, how many years is it from 19 to 67? 48. So if I divide both sides by 100,000, what's a million divided by 100,000? 10. So 10 equals e to the 48k. How shall I solve this?
Natural log.
Okay. Natural log of 10 equals the natural log of e to the 48k. So 48k equals the natural log of 10. So k, equals the natural log of 10 divided by 48. K equals 0.0480. It's actually pretty doable. Okay, you should be able to get about 5% return on your investment. So when you're 19 years old, make sure you win a $100,000 lottery and then put it in the bank, don't touch it, or invest it, don't touch it, and then you'll be a millionaire when you're 67. Good luck with that. Questions? Okay. Suppose that $10,000 is invested, and at the end of a 5-year time span, the value of the account is $13,771.28. Use the model A equals P times e to the RT to determine your average rate of return R under this continuous compounding. How will I set this up?
13,771.28 equals 10,000 E to R or 5R.
Okay. Now what? Okay. So I get 0.1377128 equals e to the 5r. Is that correct?
I think it's 1.37.
1.37? Okay. Natural log both sides. Divide both sides by 5. Let's take that to 4 decimal places, please. Zero 640. I don't know if I have this right.
You insert it back.
Yeah.
R.
Yep. So I can take 10,000 times E raised to the 5 times 0.0640 4-0. We should get $13,771.28. Questions? Okay. According to a study published in 2012, Burmese pythons are becoming the new top predator in the Florida Everglades. Not many animals in the Everglades can stand against a python that can grow 23 feet and weigh over 200 pounds. 20 pythons were recorded as captured or killed in 1995. By 2009, that number had increased to 378. Write a function of the form P of t equals P of 0 times e to the RT to represent the number of pythons captured or killed t years after 1995. Okay, so how many are we starting with? 20? Okay. How many did we end up with? Okay. So 20 times E raised to the R, and then how many years after 1995 is 2009? 14. Okay, so 378 equals 20 times e to the 14r. Okay. So I would divide both sides by 20. So I get 18.9 equals e to the 14r. So the natural log of 18.9 equals 14r. R is equal to do we get 0.20994? So use the model from part A to predict the number of pythons that will be captured and killed in 2017. Okay, so 2017 is 22 years after 1995. Okay, so 20 times E to the 0.2099 times 22. $2,025.4 pythons will be killed. Questions? Okay. Part C. If the ratio of living pythons in the wild to pythons captured or killed is approximately 100 to 1, how many pythons were estimated to be in the Everglades in 2012? Okay, so I'd have to go 2012 is how many years after 1995? 17. Okay, so $20 times e to the 0.2099 times 17. So that would give you 709. Okay? And so if the ratio is 100 to 1,
Multiply by 100.
yeah. 70,000 20-foot pythons in 2012. Yikes. What would it be right now? So we're talking 30 years?
10,300.
So they're gonna estimate that they're gonna capture, kill 10,858. So if it's still 100 to 1, see how that might be an issue down there? Yeah. Yeah. And I don't mind snakes until they get to be, 23 feet long, and then I think I'd have an issue with one. So. Do I need to do any more of these? Okay, I think I could turn you guys loose on your assignment. Like you have like 8 questions or something. I really trimmed it down for today. So tomorrow, regardless of what happens tomorrow will be review day. And then test will be on Thursday. Okay? And we still have lunch here in
Where is that?
a few minutes.